Alright guys, we're back. Here we are reviewing some algebra skills. And in this video, we're focusing on functions with tables and graphs. So previously we looked at function notation and how to interpret the different styles of a problem and how it could appear. So here we're focusing on functions and how we interact with them, tables and graphs. Okay, so let's start with, say, function f of x. It's 3x squared minus 1. And we desire to complete this table. So we wanted to know, these are our inputs again, remembering our vocabulary. We have our inputs and we want to know what the outputs are, what the results are. So we're going to place each of these values in, one at a time, into this little spot, this x, let the function manipulate that number, and see what we get out as a result. So I placed -1 in. So I think -1 times that's -1 times -1, that's +1 times 3, which is 3. Subtract 1, so 3 minus 1 is 2. Next one, place 0 in. 0 squared is 0. So 0 times 3 is 0. Minus 1 is -1. Placing 1 in. 1 squared is 1. 1 times 3 is let's say 3 minus 1 is 2 again. And then take a moment now, pause the video, and complete the last two boxes. Alright, so how'd you do? So we placed 5 in, let the function manipulate that number, we get 74. Place 10 in, let it manipulate the number, and we get 299. It's not bad, it's just kind of the same thing over and over and over again. I just realized I placed this 2 in the wrong spot, guys. My bad. So let's go back and do 3 again. 3 squared is 9, times 3 is 27, minus 1 is 26. You're probably wondering about that. So yeah, my bad. We fixed it. So when I input 1, we get 2. When I input 3, we get 26. Let's look at another example, kind of different than this one. So let's say we already have the table filled out. You already know what, say, g of -2 is. Like, we already know the function. So now we're utilizing this function to kind of complete some problems here. So now this first one, remembering function notation. This is asking, when the input is -2, what is the output? So when we place -2 into our function, what did we get as a result? We're looking here, -2, when it was placed into the function, we got 0. All right, when we place 7 into the function, okay, so when we place 7 into the function, we get a result of 27. Now what about -1? Now we notice -1 is not up here, so so let's, maybe we have a maybe some sort of relationship, quadratic, exponential, or linear. Let's look. So from 6 to 9, that's adding 3. So from 7 to 9, that's adding 3 and adding 3 again, it's 30, and yep, 33. Here I'm adding 3, that's 12, adding 3, that's 15, adding 3 again, that's 18. So it looks to be that the pattern, the rule is adding 3. So if I'm at 0 at -2, at -1 we would be at 3. Again, noticing this rule is key, and utilized it. So, changing the question. What if I want to know what the input is when we have the output? So, in this type of problem, let's see. What input gives me 9? So look at 9 here. Here's our output, so 9, input of 1. 0, okay, our input is -2. Again, we only have this set of points to look at. Maybe on the outside of this, maybe we have another value here, but we can only go off what we have for the table. And then for 12, now I'm noticing there's 12 is not here, but knowing the rule is 3, knowing the rule is adding 3, from 9, I add 3 and get 12, so it would be at 2, positive 2. Okay? So with each of these, you're just looking at a different portion of the graph and moving to the other side. So that's looking at tables. So what about looking at a graph? So what if we have this graph, h of x, because there's some function h of x that decided to use h. So what if I wanted to know where h of 2 is? So h of 2, this is again input. Remembering on a coordinate plane, the x-axis, this is our input, and the y-axis, this would be our output. So when I input 2, when I place 2 into our function, we get moving up to the graph until we get to a point, we go to and we get to 8. So again, input 2, we inputted 2 into the function. We don't know what the function is. When I place 2 into the function, this tells us that we end up at 8. Okay. So when I put in roughly 4.5, so 4.5 is roughly right in here. So I'm putting 4.5 in, moving up till we hit to the graph. It appears that we're at 4. Take a moment to do the next two, h of 10 and h of 14. All right, so did you get the answers? So h of 10, our output's 8. So 10, we go up to the graph until we hit the graph. We hit the graph at 8, therefore h of 10 is 8. For h of 14, at 14, we don't have to move up or down at all. We are on the graph, so h of 14 is 0. So again, reversing it. Now what if we have the outputs and we desire to know the inputs? Okay, so an output of 2. So we want to know what inputs give us an output of 2. So we look here, our first input appears to be 6. And we want to keep going because I notice I have this other side out here. So I keep going and it appears to be 13.5 maybe? We'll say approximately 13.5. So with each of these two inputs, our output is 2. So with 5. Output of 5. So we get a 5. Oh my goodness. Looks like we have 3 possible solutions. So we move, our first input is 4. Okay. Keep going. It appears that our next one is roughly close to 7. So it's not at 7 yet. So we'll say 6.75. Sure. 6.75, and then we can keep going, and we get to, well, 13. So we had to keep moving until we hit all points for that output. So take a moment now and find the inputs for an output of 11 and an output of 0. All right, so did you get it? H of x equals 11 might have been a little difficult because if you look at our graph, 11's up here, and there's nothing there. None of our inputs are giving us 11, so therefore no solution. That's nice. And so 0, so to give us an output of 0, the only option that gives us that is 14. So working with tables and working with graphs, some could say it's a little simpler once we understand how we work with it. So I wish you the best of luck here practicing functions with tables and graphs, guys. and I look forward to helping you with the next algebra concept. I'll see you in the next video. Goodbye.